So I said, are there any questions on the test? And everybody's just sitting there. Are we good? Everybody understand the things that they missed? I would be surprised if that was true, but, you know, maybe.
Could do number 3.
Probably so. Number 3 was actually a 3-step proof. Yeah, and actually we should definitely do either 2 or 3. So 3, because they had the same issue for some people. There was a point of confusion for more than one human in here. And so, yes, definitely. And 3 is the shorter one, so sounds great to me.
You crossed out something that's okay next to it.
That means that I at first thought it was wrong, but then it was not wrong. Okay, so we are given big sort of a thingy that doesn't look anything like that, but close enough. So W, X, Y, Z. And we are given, let's put it over here, why not? I don't know why I made a big thing when I just said it was 3 steps, but it's fine. Statements and justifications. The given is that, overall, I will say, like, some of your grades weren't what you want them to be, I'm sure. But this was one of the best overall that we've had on it. Like, nobody was, like, unbelievably off. Like, I mean, I've had people in geometry before that are just, like, clearly they were asleep every class, always. And there was none of that, which usually there's some of that. And there was, I mean, there's definitely some off stuff, but not, basically what I'm saying is, even the few of you that didn't probably make the grade that you wanted, it wasn't like you weren't you weren't an idiot. Pat yourself on the back. You're not an idiot. Good job.
Are you sure?
Yes, Helen, I am sure. Good to YZ. It's all kinds of stuff given. There's one of the givens that people were confused about. XZ, obviously. XZ bisects angle WZY. Okay, so that one right there is the one on 2 and on 3 that threw people off. We had a bisector on both of them, and there was a bit of confusion on there. Okay, so it can be bisecting 2 different types of things, right? There are really 2 different types of bisectors. There's an angle bisector, which is what this is, where this cuts the angle in half, right? And then there's a segment bisector, which this is not, which would cut the segment in half, which would tell us that this is congruent to this. Okay? So those 2 different things being separate, we got to make sure we understand that tells us 2 different things, right? If it's an angle bisector, which this one is, then it tells us that the angles it bisects are congruent. Excuse me, if it's a segment bisector, it tells us that the 2 segments are congruent, right? So the fact that, let's mark our other givens real quick. So W is congruent to Y, is in the given, so blippity blap right there. WZ is congruent to YZ, so this is congruent to that, is what that tells us, right? That's all the givens. And that's all we can say just right from the given. But something else we can say because of the given. So now, based on this, and if you got this right, I don't really want to hear from you. Because I know that's like you're going to out yourself as like, I didn't get this right. But, you know, it'll get over it. Or don't. Whatever. You know, keep your mouth shut, everybody. It's fine. Whatever. What does this actually tell us? Yeah, the two ones at Z. Yeah, so these two. Right? So we can say, because of the bisector, that angle WZX is congruent to angle YZX. Angle WZX is congruent to angle YZX. Now, you could also say, which some people did, you don't need this for this problem. You do for number 2. You would use this. Well, there's probably other ways to get to number 2, but you could use XZ is congruent to XZ because reflexive property. That is something that you could do. And that would be another way. That would actually be another way to prove this one because, well, it would not actually. You tell me. I'm going to show you in a second. If I erase, actually, I'm going to erase this, and I'm going to show you why not. Okay, so that would tell us. So you could say this: can we say the triangles are congruent?
Because we don't have not without the angle.
Not without the angle. Yeah.
Oh, you were erasing.
Yeah. Like we couldn't just do reflexive because there's no side-side angle. There's no ASS in geometry, right? Easy way to remember that doesn't exist. Yeah? There's no side-side angle. That's not a thing, right? Now, we could. Now, if we say that and this, then we have 2 ways to prove it. We could do side angle side or angle side angle, either one of those. And Bob's your uncle, right? Well, speaking of Bob, what's the justification right here?
The bisector.
Yeah, definition of bisector. Of angle bisector, I should say, yeah. What'd you say?
She said she doesn't have an unbelievable problem.
Oh, okay, that's fine. And then by angle, triangle X, I don't remember how it's written in there, but angle X, triangle XWZ is congruent to triangle XYZ. Because angle, side, angle. Because angle, side, angle. Make sense? Yeah, so this was the main point of confusion. If we bisect an angle, that says the angles are congruent. If we bisect a segment, that says the segments are congruent. So make sure you see what it's bisecting. Midpoint, really pretty, you can, well, no, not really. Midpoint pretty much only applies to segments, right? If it's midpoint, that's segments and segments only. But bisector could be either one, depending on context. And we know it's that because of that, right? Angle of the thing. Yes? Any other questions on the test? We did some arithmetic wrong on 4 and 5 some. So just check your maths. Most of our things we were set up right. And we got number 5 correct more often. Number 5 is an equilateral triangle, so all the sides are equal. So you would just set those 2 equal. On number 4, it's not equilateral. Only S and T are marked congruent. So it's a isosceles triangle. So that 2z minus 15 would equal 9, not 7. And so you wouldn't even use the 7, right? Yeah. Yeah, we did okay. We did all right on this test. It wasn't such a big deal at all. It was good. Don't forget corrections are a thing. Do them. I mean, you don't have to. And, do them. Because why not? I mean, if you made a 98, just don't waste my time and your time. Just keep the 98, it's fine. But if you made an 85, do corrections, because there was a chunk that you didn't quite understand, and so learn it. If you made a 65, do corrections, because there was an even larger chunk that you didn't quite understand, and your grade is kind of suffering, because that's below passing, yeah? If you made a 25, do corrections, please, and maybe schedule a tutoring thing with me or somebody else, because you need it. Doesn't mean you're dumb, it just means there's something that you're missing. Often, I will throw this out there strongly, that very often, if you're making, and I don't know that this applies to anybody in this class necessarily this year, but if you're making 25s on the test, probably there's a small thing that if we take 20 minutes to fix that small thing, then we're back in business. I mean, really, that happens a lot, where a student gets one thing that's confused and it is backwards or whatever, and then we fix it in 20 minutes. And then we're all back to the races. Corrections are there for you to learn. Not really, I don't really care about your grade. I really don't. And you should only sort of. Your grade doesn't say anything about you as a person. Nothing. Nothing. Not a dadgum thing. And it also isn't going to help you get a better job. There is one thing and one thing only that grades do. And even then, only sometimes and only sort of. And that's financial aid in college, and that's it. Better grades don't get you a better job. Better grades don't make you a better qualified employee. In fact, very often the C student is a better employee than the A student. Because a lot of times the A student, like what Natalie and I were talking about earlier, a lot of times the A student just, gets away with stuff and maybe works harder on the useless things than other people. The valedictorian is never, okay, maybe not never. We shouldn't use superlatives. The valedictorian is rare. I know y'all are homeschooled. You're like, I don't know what that means. But the person that has the highest grade at a public school class, they're called the valedictorian. There's usually a scholarship associated with that, which is good. Money for college can be great, can be helpful. And that's, other than that, who the heck cares? And I will note, there are other places to get scholarships. Lots of them. You could make a full-time job out of getting scholarships and not pay a dime. In fact, I know a guy that basically did that. He was homeschooled, and he, instead of working the first quite a while of college, he spent a lot of time going and getting college scholarships, and his entire college was paid for with scholarships, every bit of it.
Wow.
Yeah, and he's smart, and he's not he was homeschooled, so he wasn't valedictorian, right? Anyway, what I was saying on my soapbox was the valedictorian, that kid that makes the highest grade in the class, they're almost never the smartest kid in that class. Almost never. That's why one of the reasons why I hate that scholarship. It's stupid. It's a stupid scholarship. It pushes the wrong things. And oftentimes the valedictorian, not always, but oftentimes the valedictorian ends up dropping out of college. Very common. Very, very common. So, grades don't matter except kind of for money, and they sure as heck don't have anything to do with your worth. And they're an indication of something that you didn't quite know, so maybe learn the thing. Let's do some more math. Here we go. What lesson are we even on?
5-3.
Yeah. Inequalities. We got some exterior angles, and we've got angle side relationships. We've got all kinds of fun stuff. What numbers did we do?
8 through 36.
8 through 36. I don't know why I have 4 written through 9 and 13, but who knows? Maybe we'll find out. Probably not. Okay. Now, forgetting your pencil, that might have something to do with your worth,
That
maybe.
is for broken highlighters and pencils that can't write and have had for years. And I
You know I'm kidding.
That's kind of
No, Helen gave me one because
Oh.
she's a very nice, not.
That was
your
very
cat's
gracious
kid.
of her.
That was very gracious. Now, she's probably going to stab you with one later, but...
I will give you a pencil if you confirm that I'm not a warrior.
I already said that.
She did say that. She just said it. Yeah.
If you can
Girl.
confirm it.
I will not corroborate that statement.
No pencil.
I will write with my own blood.
Corroborate. For the record.
That's really.
For the record.
I was scared.
Are you a Warrior Cats kid?
No. No comment.
Okay. That doesn't apply here.
I
Okay.
thought I was being nice with another.
Number 8 is angle 4. Number 10 is angle 7 and angle 8. Number 12 is angle 2 and angle 5. Number 14 is angle W, angle Y, angle Z, segment YZ, segment WZ, and segment WY. 16 is angle H, angle J, angle K, and segment JK, segment HK, segment HJ. Number 18 is angle A, angle B, angle C, and segment BC, segment AC, and segment AB. Obviously, the order does matter, because that's literally the question. So we went through, what did you say? 30 something? 36. Number 20, Ben. And a sample answer would be using the triangle sum theorem, the measure of the angle across from the segment between Hannah and Gilberto is 70. Since 48 is less than 70, the pass from Hannah to Ben would, in fact, be shorter. Number 22, angle X, angle Y, angle Z. And then segment YZ, segment XZ, segment XY. Number 24 is angle 1. Excuse me. Number 26 is angle 7. 28 is angle 3. 30 is the measure of angle ABD is greater than the measure of angle BDA. 32. The measure of angle BFD is less than the measure of angle BDF. 34, segment SM is what's, I hate that they don't write it that way, it's so annoying. The measure of segment SM is less than the measure of segment MR, and 36, the measure of segment RQ is less than the measure of PQ, and 38, well, I'm going to read it anyway because I started. Measure of angle 3 is greater than the measure of angle 1 is greater than the measure of angle 2. I will throw out another piece of advice because I thought of it as I was reading things, and this is good advice, and this has been good advice, and this is why the Google Classroom is set up the way the Google Classroom is. If you are in the habit of turning in your work late because you're not doing stuff, stop it! Like, legit, stop it. Because you're hurting yourself. It's not just you getting 90s on the homework and notes grades aids instead of hundreds. That's like, who cares? Big whoop. Whatever. I know, y'all don't even know what the phrase big whoop means, but I think you can pick it up in context. Yeah? Because if you don't do the work before you show up to class, then the class time is far less valuable to you. Far less. Because you can't fix the errors that you never saw and you're seeing for the first time in class, and then you fail the quiz, and then it just snowballs into a big mess. That's why the stuff is due the day before. I get sometimes, like, okay, fine, sometimes. Sometimes you have a 4-H thing and you're out all day. Sometimes you are working with somebody. Sometimes your sibling is throwing up all night and you have to help with that. Sometimes life happens. I get it. All the things, all the layers of all the things. Sometimes late, that's fine, that's great. That's not going to hurt you much. And if you're doing it most of the time, all the time, stop it. You are hurting yourself when you do that. You're hurting, and you're hurting yourself, you're hurting your education, and you are squandering some of the money your parents are spending on this class. I'm not trying to guilt you, not really. I mean, I guess kind of I am. I shouldn't be. I'm not trying to, I don't want to do that. And I want you to take a stop and step back and think about where you are and what's going on. Because is it really your life? Or are you really just like piddle-paddling around? Like I told Natalie, some of these things I am having to relearn at 40 years old. Don't do that, folks. Don't do that. Don't waste time now and build bad habits now. I'm pleading with you. Don't do that, because I promise you don't want to do that. Life can still be great. My life is pretty dang great at 40 years old. And do your work on time, most of the time, because you can. I bet you anything you guys can. Not every time. Sometimes your siblings throw up all night, and you have to help with that.
Can you put it to the due time to be 11:59 a.m.? I mean 12:59 a.m.
No.
Oh, okay.
There's no reason for that. And see, here's, I get the question. And those snowball too. We push back, and then we push back again, and then we push back again. And I don't want you staying up that late doing it. That's not good for you either. Do it ahead of time. On Thursdays, we only ever have one lesson due. You can start it. Did you know? Here's the deal, boys and girls. Did you know that you can start your lesson for Thursdays on Tuesday?
That's crazy.
You could start it on Tuesday and then do a little bit more on Wednesday. And then if you really pushed it, you could finish it on Thursday morning, which you don't want to do because it's late and you're not listening to me because I am brilliant. That was mostly a joke. Pretty much all a joke.
We all know it's a joke.
Shut up, Helen. Anyway, what problems do we have? Yeah, you're like, quit yelling and do things, please. 22 is a fun problem. I like it. It's so grand. It's got lots of layers. It's got lots and lots of layers. None of them are difficult. X.
There's the frosting.
Y.
It's a joke.
Just to be clear, boys and girls, when I say a problem is easy, you shouldn't be like, well, I must be stupid then. Everything's difficult if you don't get how to do it. So once you get it, it's liable to be easy for you to do, but if you didn't get how to do it, you're not stupid, you just didn't get how to do it yet. And this problem's easy. I don't know why I'm so preachy today. Y'all will be fine. Maybe eventually you'll be like, you know, that weirdo was right. Okay. So, we need to figure out which angles are the biggest and all the things, which angles, which segments are the biggest, all of that stuff. So we got to be able to figure out, and we already know, boys and girls, you do know, even if you don't want to admit it, you know that the answer is not, well, obviously, y is the smallest, and then x, and then z. That's not going to get us there. That's not good enough. We got to, do a little algebra. So I think in order to figure out what the angles are, if we could figure out a way to find x, that would help, right? Because then we could shove it back in and figure out what the measures of x and y are. We know what the measure of z is, right? But, excuse me, but we got to figure out those. So how could we figure out what x is?
2x plus 1 plus 2x plus 9 equals 90.
True facts. They are.
I have a question.
I'm listening.
So, since both variables are x and they're both 2x, can't we know that y is bigger because we're adding 9 to it? And with x
So I would accept that like written out as an answer. Yes. Yes. Because like if you wrote that in enough words that I could understand what you were saying, yes, I would accept that as all the work. Yes. Yes, I would. Yep. Yeah. That absolutely fits in the theme of the class. So, yes. And we can do it with some algebra, but yes. And if y'all didn't hear or understand what Reese just said, don't worry about it. So we're going to use a different tool. This equals 90. We know it equals 90. We know it's complementary because this one's 90. So those two have to add up to 90, right? Because 180A is the measure of all of them, right? Okay, so now we can solve this little thing. So what do we do to solve it? Combine like terms. Four x plus 10 equals 90, yeah? And then we'd subtract the 10. 4x equals 80. Divide by 4. X equals 20. Then what could we do?
plug x back in both.
Plug back x into both. 2 times x. 2 times 20 is 40, plus 1 is 41. 2 times 20 is 40, plus 9 is 49. No, z is 90. Z is the biggest.
Lowest,
Is it lowest to highest? What does it say?
smallest to largest.
Yeah, smallest to largest. So angle x, angle 9, angle z, and then segment zy, segment xz, segment xy. Clearly, I drew it perfectly.
You drew it just how the book has it, though.
Yep. And they did that on purpose. What do you want to bet? Because if you would have been just like, oh, look at it, obviously, you would have got it wrong. Yeah. But either the logic method to solve this problem, which is great, and if you understood what Reese said, that's great, and you want to use something like that in the future, that's great, or the algebra method, either one, getting us there, that's the answer. Either way is great. We get to do inductive or deductive reasoning.
Can we do 12?
We could do 12. I'd be happy to do 12. Twelve is exterior angle theorem. And we've got 8 and 9 and 7 and 2 and 3 and 6 and 4 and 5 and 1. And for 12, we're trying to find measures greater than 8.
Would it be 9? This is
And it's got to be, so this problem would be very tempting to be a just look at it problem, right?
Yeah.
And we can't do that. We've got to list the ones that we can say for sure are, right? That's what we've got to do, right? Because 9, assuming this is drawn, scale and whatever, 9 looks like it's more, but we can't really prove that. There's nothing that quite lets us do that. So which ones can we say for sure? Okay, 5, why?
Because it's equal to 7 plus 8.
Yes. So this triangle, this is the exterior angle with these, this is the opposite exterior angles, right? The far ones. So this has got to be this plus this. So angle 5 we can say, because if we've got to add 7, so angle 5. And there's one more.
2 because it's equal to 6 and 8.
That's right. That's right. So 6 and 8, 6 plus 8, this would be the exterior angle that's on the outside that goes with these two, right? So 6 plus 8 is 2. So also angle 2.
Is it also angle 4? Because it's...
No, okay, and I'll show you why. It looks kind of like it would be, but this has to do with a different triangle, right? Because this line,
Oh, because the line doesn't...
yeah, if it was, yeah. Well, even if it did, like this is, like it would actually be, let's see,
Yeah, because that one...
it would be like this one, this one. Like that one would be it. The one that's, so part of 4 and 3 would be the one that would go with those on that side.
Would 8, could that only be 4?
What?
For problem 8?
Oh, on problem number 8. Let me see. Is this the same picture? Yes, only 4. Yeah. Yeah. With this problem or what Stephen was talking about?
This problem,
Okay, let me pop it. Let me see if I can kind of keep this up here and get rid of the blood and pull some stuff out and see if we can make it more clear. Okay. Okay. So we're talking about this triangle. So let me draw that triangle by itself. Okay. So we've got 7, we've got 8, and we've got 6. And then the only lines that are on there, so the only lines that are numbered is we've got a line coming off of here, and this is labeled as 5. We've got a line coming off of here, and this is labeled as 2. This one is labeled as 9. That's these ones. And so that's the only triangle we have. Now, this, something that's a little bit confusing, is we've got another triangle over here that's got like a 4 thing, but that's something up here, right? There's nothing, 4 doesn't have 2 things that are in this triangle. Like this would have to continue up here. This would have to go this way for us to be talking about something useful. So 4, I'm going to pretend like 4, we'll probably come back to 4 here in a second, but pretend like it doesn't exist in the problem for a second. So what the problem is asking, based on this picture, this new picture, is we have angle 8, and it says using the exterior angle theorem. What does the exterior angle theorem say?
Wait, what?
What does the exterior angle theorem say?
Oh, the one in the these given angles are together equal to one that's
Exterior, right? Yeah. So which angles are, if we look at 6 and 7, which exterior angle are we interested in? 9, right? If we look at 7 and 8, which exterior angle are we interested in? 5. If we look at 6 and 8, which exterior angle are we interested in? 2. So the question says, which ones have to be bigger than 8, right? Okay, so it would be the ones that are on the outside that have to do with 8. So like these two, 5 has to do with 8, because 7, if 8 plus 7 is 5, then 5 has to be bigger because we have to add this to get to it.
So how do we get 4?
We didn't get 4. 4 is not an answer on this problem.
Oh, okay.
4 is not an answer on this problem. I'll come back to 4 in a second. So also 2 has to be bigger because then it would be 8 plus 6. And if we've got to add 6 to 8 to get 2, then 2 has to be bigger than 8, right? So those ones work. Now the 9, we can't say because of that. We don't have enough information. It looks bigger, but we can't prove it, right? Because it's a linear pair, but does that make sense? Okay, good, good. Okay, now 4 is the one that's a little bit confusing, right? Because we got some other stuff happening at 4. So we've got, I'm going to just draw the little top hat. We've got this line drawn on the page, and then we've also got a line over here. This is angle 4, and this is angle 3. So if I want to draw the one that actually is exterior with 7 and 8, it would be this one. So let's call this angle 10. I'd have to extend this line out. So I've got this one and this one extended. So this one's extended, which makes sense because look here, everybody. What are angles 10 and 5 on this picture? What are those? They're vertical angles. What are vertical angles? Congruent. So it makes sense that those are congruent. But since 4 is not that, because 4 doesn't have that one, and it has another little thing going over here, right? So 4 is this. Yeah, so 4 isn't that. Does that make sense? Good. Grand. Any other questions? We should do a quiz. We haven't had that in a while. Sounds fun. I love it. Quiz 5-1. Page 348. Numbers. Excuse me. One and 5. Don't forget to put your name on it.